Hello friends, I am Nehal Jain from qcfinancein. Today's topic is integration and differentiation using Matlab. Today I will cover some topics such as functions and symbolic differentiation, integration to find arc length, singularity on interior of integration domain, and analytic solution to integral of polynomial. Now the first topic is our functions. Here are some functions with their descriptions, such as if you want to numerically evaluate integral, then you have to use the function integral. Similarly, here are the list of some functions that you can try on the Matlab for integration and differentiation. Now coming towards the functions and symbolic differentiation. In Matlab, the fundamental difference between a function and a symbolic expression is that a function can be called with arguments and a symbolic expression cannot be called. On the other hand, you can say that a symbolic expression can be differentiated symbolically, but a function cannot. Matlab can be created in two ways: function M files and as inline functions. Let's see. A typical way to define a symbolic expression is here I am defining a symbol x as symx and a function of x, that is f equal to x square sine of x. Okay, now we are getting the function x square minus sine of x. Now the next point to be noted is you can differentiate the function f, but you cannot evaluate it, at least in the obvious way that we use. In the Matlab, we can notice in the Matlab that it recognizes the variable. In case of several symbolic variables, we can specify the one with respect to which we want to differentiate. Such as here you can see that if I give the command diff f, that is differentiation of f, then I'll get the answer to x minus cos of x, that is a differentiation of the function x square minus sine of x. But if, such as in the Matlab, I have given the diff of f and I got the answer as 2x minus cos of x, that is the differentiation of this function. But if I want to calculate the value of this function, then I cannot. Just such as I have given f of 4, then air is as the output. So this shows that we can evaluate f of 4 by substituting 4 for x, or in the other words you can say by typing sub s of f comma x comma 4, then you will get the answer as 16. Okay, now you can also turn f into an inline function with the command, such as if you want to convert it as an inline function, then you have to give the command f in equal to inline of character of function f, then the output will be this. This shows that inline command requires a string as an input, and character turns, that is char, turns f from a symbolic expression to the string x square minus sine of x. Now if we had simply typed f in equal to inline of f, then we could have got an error message. Since f is not a string here, therefore we have to use the char of f for converting it in an inline function. Now if you give f in of 4, it will give you the output. Now similarly we can also construct a function from the derivative of f. For example, using the differentiation of f, converting it into the string and then making it an inline function, you can get the fx of n. Here is the command for that. So we have seen that the function char replaces its argument by the string and thereby making it available to the function as inline that demands string as input. Okay, now however, when char is applied to a symbolic expression, the result is still symbolic and can be symbolically differentiated. For example, you can also differentiate the character of f that you can see on the screen. Now the other way to create a function that can be evaluated is to write a function m file. Now this is a primary way to define a function in most applications of MATLAB. You can also use it relatively. Now the m file cannot be created inside a document such as this, but must be separate. We have written the m file fun1.m. You can see the text by following this function fun1 of 4, and you can get the output. Now here are 5 steps for solving a problem of differentiation. Okay. You can try it on the MATLAB software and see the output. Now coming towards the symbolic and numerical integration. The int function is a symbolic integrator that easily integrates the f function. Let's see it on the MATLAB screen. Here I have used the int function int sf equal to int of f comma 0 comma 2, and the output the MATLAB will give is cos of 2 plus 5 oblique 3. In this way it integrates. But if you replaces the function f by another function, say h, that is we are taking square root of x square minus sine of x to the power 4, then int will be unable to evaluate the integral of it, and you will get a warning error. So for this you have to type double in front of the integral expression, and then the MATLAB will return the result of a numerical integration, such as type double of int of h comma 0 comma 2 and close the brackets. Then you will get the output as 1.7. Now switching towards the integration to find the arc length. We are having the function x of t, y of t and z of t as sine 2t, cos t and t, and that t ranges between 0 to 3 pi. First of all we have to give the command for t and this function. Now for the range of t we have to give the command t equal to 0 difference 0.1 to 3 pi, that you will write 3 into pi. Now for creating the plot of x of t, y of t and z of t together, you have to give the command plot 3 in bracket, give the value sine of 2t, cos of t and t, that is x of t, y of t and z of t. After giving this command you will get a plot on the MATLAB. Now here is that figure that you will get after the command plot. It is the plot of x of t, y of t and z of t. Now for finding the arc length, you have to first differentiate x of t, y of t and z of t, then square it and add it. That we have done here. This is the square of the differentiation of xt, square of differentiation of y of t and square of differentiation of z of t. We have added it and take it under a square root, and then we will integrate it from 0 to 3 pi. Now for this we have to give a command for this function such as f equal to @ t, that is the limit of t we are having 0 to 3 pi, and we will define this in the command as square root of 4 cos of 2t dot to the power 2 plus sin t to the power 2 plus 1. And now finally for calculating the length you have to just use the function integral of f comma range of t, that is 0 to 3 pi, and you will get the answer. Now coming towards the singularity on interior of integration domain. We will see this example in 3 parts. That is, first is we will define the integrand with an anonymous function, then we will integrate it over a square, and then we will split the integration domain into 2 triangles. Now the first part will be define the integrand with anonymous function. Here the function is 1 upon under root x plus y, and it has the singularity when x and y are 0 and is in general singular on the line x equal to minus x. For defining the function, we have to write the command func, that is a function equal to at the rate x comma y. This is written because of the differentiation, that is we are differentiating this function with respect to x and y. Therefore we have to write at the rate x comma y, and then we will define the function, that is 1 upon under root 1 x plus y. Now we will integrate it OS domain, that is x ranges from -1 to 1 and y from -1 to 1. For this we have to write the command format long and integral 2 of function and the ranges of x and y. But the output of this will be a non-finite result. So if there are singular values in the interior of the integration region, then the integration fails to converge and returns a 1 like this. Now the third part, that is split the integration domain into two triangles. For this you can redefine the integral by splitting the integration domain into complementary pieces and adding the smaller integration together. Now to avoid the integration errors and warnings by placing singularity on the boundaries of the domain. In this case you can split the square integration region into two triangles along the singular line y equal to minus x and add the results. Such as we have done here, we have splitted it into q1 and q2 and then we have added it, and the output here will be as it is, q equal to 3.77 minus that you can see on the screen. Now the exact value of this integral is 8 root 2 by 3 1 minus I, and you can find the answer of this. Now coming towards the analytic solution to integral of polynomial, it is the last topic. Now in this example it will show how to use the polyint function to integrate the polynomial expression analytically. Use this function to evaluate indefinite integral expressions of polynomials. The steps that we are going to use are: first we will define the problem, then we will express the polynomial with a vector, and finally we will integrate the polynomial. Now as per our first step, that was define the problem, we are considering a real value indefinite integral, that is 4x to the power 5 minus 2x cube plus x plus 4, and we will integrate it with respect to x. Now the integrand is a polynomial, therefore the analytic solution will be 2 by 3 x to the power 6, that is we have done simply the integration, and here the k is for the constant of integration that is in the integration rule. Now since the limits of the integration are unspecified, we do not know the limits, therefore the integral function family is not well suited to solve this problem. Now the second step was to express the polynomial with a vector. For this, create a vector whose elements represent the coefficient for each descending power of x. Here we have taken p as a vector, which is 4, 0, minus 2, 0, 1 and 4 are the elements of the vector p. These elements of 4 are the coefficient of the x that we have taken the x function in the starting. This we are taking the elements of the vector as the coefficient of x, that is 4. The x to the power 4 is not here, therefore 0, 2, minus 2, again 0, 1 and 4. Okay, so in this way we have taken the vector p. Now the third part was to integrate the polynomial. In this, for integrating the polynomial analytically, we use the polyint function. It specifies the constant of integration with the second input argument, that is we have taken k equal to 2, second argument, and I equal to polyint p comma k, that was the constant, integration constant, and here we get the output as I equal to 0.660 minus 0.50, 0.54 and 2. Now the output is a vector of coefficients for the descending power of x, that same way where we have taken as a vector p elements. Now this result matches the analytical solution above, but it has a constant of integration k equal to 2. So in this way you can calculate the analytic solution for integral of polynomial. These are the references that you can see. Thank you.